Hello all, welcome back to another video. In this session we are going to discuss some important questions, important previous year questions and its explanations from reinforced cement concrete. So watch the video completely without skipping, and if you find the video more helpful, then you please subscribe my channel for getting more videos. So move on the question. First question, here gives 4 options and assertion and reason is given. After reading this assertion and reason, find out which statement is correct. Assertion: in the working stress method, the stress in compression steel is taken as 1.5 into modular ratio into stress in surrounding concrete, and the reason is given as the modulus of elasticity of concrete in compression is only 2/3 of that in tension. And the 4 statements are both A and R true, and R is the correct explanation of A. And second option is both A and R true, but R is not a correct explanation of A. And option C, A is true but R is false. And option D is A is false but R is true. Let's see which is the correct answer. So in this question the correct answer is option C. And let's see the explanations also. According to IS 456/1978 code, the permissible compressive stress in bars, beams or slab when compressive resistance of the concrete is taken into account, it can be taken as 1.5 into m times the compressive stress in surrounding concrete, that is 1.5 into m into sigma CBC, or permissible stress in steel in compression, that is sigma Sc, and whichever is less. Next question, assertion is given as losses in pre-stress of pre-tension beams are more than the losses in post-tension beams, and the reason is given as this is partially due to the effect of elastic shortening. So the 4 options given us both A and R are true, and R is the correct explanation of A. And the second one is both A and R are true but R is not a correct explanation of A. And the next option is A is true but R is false, and option D, A is false but R is true. So let's see the which is correct answer. Option A is the correct one. So here gives the explanation. Losses due to various terms is given. Corresponding pre-tensioning and post-tensioning values is also given. First one, loss due to elastic shortening, pre-tensioning 3 and post-tensioning 1. Next is creep of concrete, pre-tensioning 6% and post-tensioning 5%. Next is shrinkage of concrete 7% and 6% in case of post-tensioning. And next is creep of steel, pre-tensioning 2% and post-tensioning 3. Therefore total 18% in case of pre-tensioning, and for post-tensioning 15%. So losses in pre-tensioning is more than post-tensioning. Then next question. First one is assertion. The development length for HYSD Fe for 15 bars is less than that of mild steel plain bars, and the reason is given as the permissible bond stress for HYSD Fe 415 bars is more than that of mild steel plain bars. And here is given 4 options. First option, both A and R are true, and R is the correct explanation of A. And second option, both A and R are true but R is not a correct explanation of A. And the third option, A is true but R is false, and the option D, A is false but R is true. Here the correct answer is option A. Let's see why it says like that. Development length of bars, it is denoted by LD and is given as psi sigma x by 4 tau BD. Psi denotes nominal diameter of bar, sigma s stress in bar at the section or considered at design load, and tau BD denotes design bond stress. So design bond stress in HYSD bars is 60% more than that of mild steel plain bar. So development length is less in HYSD bars. That is here development length is inversely proportional to tau BD. So next we are moving to the next question.
assertion is given as bridges designed for class AA loading should be checked for class A loading also. Reason: under certain conditions, heavier stresses may be obtained for class A loading. So the four statements, both A and R true and R is the correct explanation of A. Second option, both A and R are true but R is not the correct explanation of A. Third option, A is true but R is false. And then fourth option, A is false but R is true. So let's see which one is the correct answer. Option A is correct. Both the statements are correct and R is the correct explanation of A. Why it comes, we'll just go through that. IRC class AA loading. It is used in the design of new bridge, especially heavy loading bridges like bridges on highways, in cities, industrial areas, etc. Next, IRC class A loading. It is used in the design of all permanent bridges and it is considered a standard live load of bridge. So when we design a bridge using class AA type, then it must be checked for class A loading also. And next is IRC class B loading. It is used to design temporary bridges like timber bridge, etc. and it is considered as live loading.
Thanks for watching.